Hello everyone, my name is Anmol Saini and I am your chemistry SME. Today we are solving FLT-1 questions. Okay, so let's start. So the first question is match the following question. Okay, so here is the column 1 and column 2. Okay, so first is Friedel-Crafts alkylation of benzene gives. Okay, so we know using Friedel-Crafts alkylation of benzene, toluene can be formed. Okay, toluene can be formed by using the reactant benzene plus CH3Cl by using and the reaction is Friedel-Crafts alkylation reaction and this will give toluene. Okay, option number B. Okay, now Wood's reaction of chloroethane. Wood's reaction of chloroethane. Ethane means we have two carbon, but in Wood's reaction, the number of carbon just double. Okay, so it means from ethane, butane will form. From ethane, butane will form. Okay, so option number 3 will be its answer. Now, reduction of acetic acid with lithium aluminium hydride. Okay, we know lithium aluminium hydride is a strong reducing agent. Okay, so it will directly reduce acetic acid to the ethanol. Okay, it will reduce to the OH group, directly to OH group. Okay, so option number C, it will be ethanol, because there is two, in acetic acid there are two carbon compounds, and ethanol also two carbon compounds. There will be no change in the number of carbons. Okay, now hydrolysis of benzyl chloride. Okay, we know hydrolysis of benzyl chloride will reduce it, it will oxidize it, and after oxidation it will form benzoic acid. Okay, so the correct option will be option number 1. Now question number 52. Question number 52 is a very famous and very easy question. Okay, so uh, this type of questions are very famous in NEET and in JEE mains also. Okay, so the question is you are given with a compound and first reaction will be ozone lysis reaction and the second reaction is OH minus in presence of heat. This reaction is aldol condensation. This type of questions are very famous and very important as well. Okay, so first of all, O3 and Zn. We know this reaction is ozonolysis reaction. Ozonolysis reaction. Okay. So first of all, here is the reactant and here is our O3 means ozone. Okay. So when ozonolysis reaction will take place, this double bond will break and two double O group will form here. Okay. So after ozonolysis, this product will form. Okay. Now we have OH minus and heat. These are the reactant for aldol condensation. For aldol condensation or aldol reaction. Okay. Now in aldol reaction, when this OH group will be removed, then after rearrangement to this carbon, because we know 6-member ring is the most stable. After that 5-member, and after that 7-member ring are stable. Okay, so after the rearrangement and the stability, 5-member ring will form on that side and 7-member of carbon ring will form on that side. 5 carbon, 7 carbon. Okay, and after their rearrangement you will get this product. Okay, so this is given in option number 2. Okay, so first we are doing ozonolysis reaction followed by aldol condensation reaction, and we know when aldol condensation reaction will take place, when there will be alpha hydrogen. If there is no alpha hydrogen, means no aldol condensation will not take place, then Cannizzaro reaction will take place. Okay, now question number 53. The major product formed in the reaction of propene with HBr in presence of peroxide. Okay, so we are given with propene, means 1, 2, 3 and propene. Now reaction with HBr. Now propene on reaction with HBr here. So this Br group will formed at will leave from the H and will attach to one of the carbon, and this can be measured by anti-Markovnikov rule here. Why anti-Markovnikov rule? Because peroxide is there. Peroxide means H2O2. When peroxide is there, then anti-Markovnikov rule will be followed. When there is no peroxide, then Markovnikov rule will be followed. Okay, so Br, then this double bond will remove and Br will form that here. Okay, so option number 1 will be our correct answer. Okay, when there will be no H2O2, then Br will be Br will attach to the carbon number 2. Okay. Now question number 54. Which of the following does not undergo aldol condensation? Okay, so we know that any compound will go under aldol condensation when the reactant will be OH minus and heat. This is the condition, and the main condition is when the compound is having alpha hydrogen. If any compound is having alpha hydrogen, then then that compound can go under aldol condensation. If there is no alpha hydrogen, then no aldol reaction will take place. Okay, so in propanol means 1 2 and CHO group. Yes, there is alpha hydrogen, so it will undergo aldol condensation. Ethanol, in ethanol there is also alpha hydrogen, so it will also go under aldol condensation. In propanone there are also alpha hydrogen, so it can also undergo aldol condensation. But in benzaldehyde there is no alpha hydrogen. If there is no alpha hydrogen, means it will not undergo aldol condensation reaction. So option number 4 will be our correct answer. Now question number 55. Enzyme function as biological catalyst by lowering the activation energy of reactions. Yes, this statement is correct, because the use of enzymes are to lower the activation energy so that reaction can take place fastly. Okay, and the reason is enzyme provide an alternative reaction pathway with a lower energy barrier. Yes, this reason is also correct, because enzymes provide the alternative way from which a reaction can take place from the reactant and form a product. Okay, so it provide a alternative path which is having lower energy barrier. Lower energy barrier means low energy gap. Okay, so assertion is correct, reason is also correct. So option number A is our correct answer, and it is explaining the assertion as well. Okay, so option number A is our correct answer. Now question number 56. Which of the following type of bond are primarily responsible for the dipole moment in organic molecules? Okay. So uh, we know uh, the dipole moment is due to the difference between the polarity of charges, difference of positive and negative charge. Okay, so dipole moment arise due to the unequal sharing of electron in polar covalent compound, resulting in a partial positive and partial negative charges, means delta plus and delta minus charges. Okay, so it arises due to the polar covalent bonds. Now question number 57. The IUPAC name of the compound. Okay. So we have to write the IUPAC name. First of all, we have to count the number of carbon. 1, 2, 3, 4, 5, 6, and then 7. No, 1, 2, 3, 4, 5, 6. So it is having 6 carbon. Now we have to starting the numbering. So we know numbering will be starting from that position from where the functional group will get the lowest number. Okay, so numbering will be starting from this side: 1 2 3 4 5 and 6. And now we can directly write the name. Now there is 6 number of carbon, means hex. Now double bond on the third position, means 3 in, and aldehyde Al on the first position, means option number 2 is our correct answer. Now question number 58. The major product of the Reimer-Tamer reaction is, okay. So we know Reimer-Tamer reaction is a very common reaction, and the major product is salicylaldehyde. Okay. The Reimer-Tamer reaction introduces a formyl group CHO ortho to the hydroxyl group in phenol, forming salicylaldehyde. Okay. Just a second. And the structure of salicylaldehyde is given here. I am just drawing as well. This is the structure of OH and CHO. This is the structure of salicylaldehyde. Okay. Now question number 59. The molecular formula of a hydrocarbon is C5H12. The compound is, okay. So whenever a chemical formula is given and asking for the compound name or asking the type, then don't try to directly draw the structure. Just use the common sense. Can we directly predict it? Yes. In this question, we can directly predict because for alkane, the general formula is general formula is CnH2n plus 2. In alkene, the general formula is CnH2n, and similarly for alkyne CnH2n minus 2. Okay, so here is number of carbon is 5, means n value is 5, and H2n plus 2 means it is following 2n means 10 plus 2 is equals to 12. So the general formula is following alkane. Okay, so the compound is an alkane. Option number 1 is our correct answer. Now, Lysine test is used in quantitative analysis to detect. Okay, so we know Lysine test is used to detect nitrogen, sulfur, and halogen. All these three can be detected using Lysine test. So option number 4, all of these is the correct answer. Okay, Lysine test is used in the quantitative analysis to detect nitrogen, sulfur, and halogen in organic compound by converting them into ionic form, which is cyanides, sulfides, or halides that can be identified using specific chemical reactions. Now, question number 61. Which of the following compound give a positive iodoform test? Okay, so we know the compound which is having CH3 C double bond O R. When there is CH3 C double bond O R group present in a compound, then that compound can give the positive iodoform test. Okay, so in these four compounds we have to check which of the following is having this group. Okay, so benzaldehyde, uh, we know benzaldehyde does not have this structure present. This is the structure of benzaldehyde, so no, this group is not present. In propanoic acid, also not present. In methanol there is OH group, so not possible in methanol as well. But in acetone, the structure of acetone is CH3 CO CH3. So CH3 C double bond O R group is present in acetone, so correct answer is option number 4. So 61 is done. Now question number 62. Match the following compound with their characteristic reactions. Okay, so first of all, we will start with benzaldehyde. Okay, so the structure of benzaldehyde is, this is benzene and aldehyde group on the top. Okay, so generally benzaldehyde show nucleophilic addition reaction. Okay, generally benzaldehyde show nucleophilic addition reactions. Now phenol, the structure of phenol is benzene and then OH group. Okay, so phenol is a kind of activating group due to the phenoxide ion present in it. Okay, so that's why it is an it can give electrophilic substitution reactions. Okay, because it is an activating group due to the phenoxide ion. Okay, now acetone, we know the structure of acetone is CH3 CO CH3. Okay, so this is having an alpha hydrogen, so this can easily give aldol condensation reaction. So now ethanoic acid can give esterification reaction. We know ethanoic acid and alcohols are used for making the esters. Okay, so when we rearrange all this option, we will get option number A will be our correct answer. Okay, now question number 63. Okay, question number 63. The best reagent for converting benzaldehyde to benzyl alcohol. Okay, so we have to convert benzaldehyde to benzyl alcohol. Okay, means this 2OH. Okay, so this can be we know this is a reduction reaction. This is a reduction reaction, so we need a reducing agent. Okay, so lithium aluminum hydride is a reducing agent. Yes, it is a reducing agent. KMnO4, no, it is an oxidizing agent. Na2Cr2O7, this is also an oxidizing agent. N2 and PD, H2 and PD, yes, this is a reducing agent as well. But lithium aluminum hydride is a strong reducing agent, and a strong reducing agent is required here to convert benzaldehyde directly to the benzyl alcohol. Okay, so the best reagent will be lithium aluminum hydride. Okay, so the correct answer will be option number A. Okay, the correct answer will be option number A. Now question number 64. Which among the following compound does not show tautomerism? Okay, which of the following does not show tautomerism? Okay, so tautomerism requires the presence of a alpha hydrogen, requires the presence of a alpha hydrogen adjacent to a carbonyl group. Means if this is a carbonyl group, then on this carbon a alpha hydrogen is required. Okay, alpha hydrogen is required. Ethanol does not meet this criteria. Okay, so this criteria is does not fulfill on ethanol. That's why ethanol can't show tautomerism. Okay, because we required an alpha hydrogen adjacent to a carbonyl group. Okay, so option number second is our correct answer. Now question number 65. Which of the following compound will not exhibit resonance? Okay, we have to tell which of the following compound resonance is not possible. Okay, so first of all, phenol, we know the structure of phenol is this, and yes, resonance is possible in phenol. Okay, now alanine, the structure of aniline is benzene group and then NH2 group in this. Yes, resonance is also possible in aniline as well. Now in benzyl chloride, because of the large Cl group, the resonance is not possible here. Okay, so option number C is our correct answer. And acetophenone, yes, in this compound resonance is also possible. Okay, the resonance require conjugation of pi electron with adjacent p orbital. Benzyl chloride does not have conjugated pi electrons near the benzene ring. That's why it cannot show resonance. Okay, now question number 66. In the reaction, the next compound C is, okay, so we are given with the reactant pH, C double bond O, CH, and 2 Br group are attached to the carbon. 2 Br group are attached to this carbon, and we are reacting with aqueous OH, with aqueous OH minus, with aqueous base. Okay, so when we will react with aqueous base, then pH, C double bond O, C, H, and double bond. This compound will form. Now we are react. This is our compound A. Now we are reacting this compound with concentrated OH minus. Concentrated OH minus. Okay. So we know in the above compound A there is no alpha hydrogen. If there is no alpha hydrogen and there is OH minus, then Cannizzaro reaction will take place. If there is alpha hydrogen, then aldol condensation. If there is no alpha hydrogen, means Cannizzaro reaction. When Cannizzaro reaction will take place, then the compound form will be pH, OH, COO minus. Now at last, we are reacting compound B with H plus. When we will react this compound with H plus, it will form pH, CHOH, and COOH group, means acid group will be formed. Okay, so clearly option number C will be our, option number 3 will be our correct answer. Option number 3 is our correct answer. Now question number 67. Question number 67, yes. Here we are having the compound Z. We are reacting with PCl5. Then we are reacting with alcoholic KOH. Then we are reacting with dilute H2SO4. Okay. And then we have to, then the product Z will form. Okay. So we have to identify the compound Z. Okay. So there are many ways to solve these type of questions. You can solve by backtracking, or you can solve by option as well. Okay, so let me show you option wise option. So first we are taking CH3 CH2 OH, means we are taking ethanol. So CH3 CH2 OH. When we will react with PCl5, then this OH group will be removed and then Cl group will attached on the this carbon. Okay, now we are reacting with alcoholic KOH. When we will react the compound with alcoholic KOH, it will remove this Cl group. When this Cl group will be removed, then C2H4, C2H4, you can directly say ethene will be formed. Okay, ethene will form. Now we will after the product Y is ethene. Okay, now we are reacting ethene with dilute H2SO4. When we will react ethene with dilute H2SO4, the compound will be CH3 CH2OSO3 OSO3 OSO3H. This compound will form. This group will be attached. OSO3H. This group will attached. Now, when we will react this compound with H plus H2O in presence of heat, then again it will converted back to the ethanol, which is CH3 CH2OH. Okay. So our correct answer is option number 1. Now question number 68. Question number 68. The correct sequence of increasing covalent character is represented by, okay, so we have to tell the order of increasing covalent character. Okay, so we know we can comment on covalent character by using Fezan's law. Okay, comment on covalent character by using Fezan's law. Okay, the covalent character increases the increase with higher charge density and smaller size of the cation. Okay, now BeCl2, which is beryllium chloride, has the highest covalent character due to Be plus 2 ion, while lithium plus is smaller than Na plus. Yes, leading to LiCl having higher covalent character than NaCl. Okay, so this is very much clear with the statement written here. So the lowest covalent character will shown by NaCl, followed by lithium chloride, followed by beryllium chloride, BeCl2. Okay, so option number 3 is our correct answer. Now question number 69. Which of the following is not a correct statement? Okay, so we have to tell which of the following reaction is incorrect. Okay, now for checking statement 1, the canonical structures have no real existence. Yes, this statement is true. Okay, every AB5 molecule does in fact have square pyramidal structure. Okay, we will check statement number 2. Okay, we are checking the further statements now, because for this we have to calculate. Option number 3, multiple bonds are always shorter than corresponding single bonds. Yes, this statement is true, because triple bond is having the lowest bond length, followed by double bond, and then followed by single bond. So this statement is correct. The electron deficient molecule act as Lewis acid. Yes, this statement is also true, because electron deficient compound act as Lewis acids. So clearly option number 2 is our correct answer. Now question number 70. Which one of the following is the correct order of interactions? Okay, so we have to tell the order of interaction of these forces. Okay, so we know van der Waals force is the weakest force interaction, van der Waals is the lowest, followed by dipole dipole, then we have the hydrogen bonding, and then we have the strongest interaction, which is covalent bonding. Okay, the strength of interaction increases in this order, which is weak van der Waals forces, dipole-dipole interaction, strong hydrogen bonds, and then followed by very strong covalent bonds. And we know covalent bonds are formed by the sharing of electrons. Okay, so the correct option will be option number C. Now question number 71. Standard enthalpy of vaporization, which is delta H for water at 100 degrees Celsius, is 40.66 kilojoule per mole. The internal energy of vaporization of water at 100 degrees Celsius is, so we have to calculate the internal energy. Okay, so we can directly use delta H is equals to delta U plus P delta V, and here we are given that it can act as an ideal gas. Okay, so from ideal gas we can write PV is equals to nRT. This is the expression for ideal gas. Okay, so in this place we will write nRT. So delta H is equals to delta U plus nRT. Now putting all the values, so we have to calculate the delta U, so put it on the left hand side, then nRT minus delta H. Okay, nRT minus delta H. So here delta H is given, which is 40.66. Okay, 40.66, 40.66. Now we have to calculate nRT. So yes, this is correct. So delta, we have to calculate. So this is the wrong. Delta U will be equals to delta H minus nRT. This will be the correct. Okay. So now putting the value of delta H is 40.66. Now we have to calculate the nRT. So nRT I have calculated here. The value of n is 1 because we are calculating for 1 mole. Then the universal gas constant value is 8.314 and the temperature is 373 Kelvin. Okay, so here we can calculate the value of nRT, and this it will give 3.1. The value of nRT will be 3.1. Okay, so 40.66 minus 3.1, it will give the value of 37.56 per kilojoule per mole. Okay, 37.56. So option number 1 is our correct answer. Now question number 72. Question number 72. Given the reaction between two gases represented by A2 and B2 to give the compound AB. Okay, so this is the reaction which is A2 plus B2 gas is giving AB gas. At equilibrium, the concentration of A2 is 3 into 10 raised to the power of minus 3 molar. Concentration of B2 is 4.2 into 10 raised to the power of minus 3 molar, and the concentration of AB gas is 2.8 into 10 raised to the power of minus 3 molar. If the reaction take place in a sealed vessel at 527 degrees Celsius, then the value of Kc is okay. So we directly have to calculate the value of Kc, equilibrium constant. Okay, so we know the value of Kc will be the concentration of all products and the concentration of all the reactants. Concentration of all the reactants. Okay, so Kc here is product is AB. The concentration of AB is 2.8 into 10 raised to the power of minus 3, and the stoichiometric coefficient is 2. So 2 will come in the power. Now the concentration of product are 3 into 10 raised to the power of minus 3 into 4.2 into 10 raised to the power of minus 3. So if we solve this calculation, the answer will be close to 0.62. Okay, so the value of equilibrium constant will be 0.62, which is option number 3. Now question number 73. Calculate the value of POH for a solution at 25 degrees Celsius that contain 1 into 10 raised to the power of minus 10 molar of hydronium ion. Hydronium ion means H plus ions. Okay, so we have to calculate the POH value. So first of all, we can calculate the pH. We know pH is equals to minus log of H plus ion, log of H plus ion. So minus log 10 raised to the power of minus 10. Okay, so 10 raised to the power of minus 10, this will directly give the value of 10. So pH is equals to 10. Okay, and now we also know that pH plus POH is equals to 14. Okay, so the value of pH is 10, so automatically the value of POH will be 4. Okay, so the correct answer will be option number 1. Now question number 74. The oxidation state of chromium in CrO6. Okay, the given compound is CrO6. Okay, so we know the maximum oxidation state possible from chromium is +6. Okay, we can directly comment on the oxidation state by drawing the diagram, but CrO6 is a very common compound in which oxidation state of chromium is generally asked. So here we have just to remember that the oxidation state is +6, or you can calculate by drawing the diagram as well. Okay, so correct answer is option number 4. Now question number 75. A solution of acetone in ethanol show positive deviation from Raoult's law, behaves a non-ideal, obeys Raoult's law, show a negative deviation. Okay, so which of the following is correct? Okay, so solution of acetone in ethanol show a positive deviation from Raoult's law. Okay, A solution of acetone in ethanol show a positive deviation due to the breaking of hydrogen bonding between ethanol molecules caused by addition of acetone. This result in weaker intermolecular forces with a high vapor pressure than expected, leading to a positive deviation from Raoult's law. Okay, so option number 1 is our correct answer. Now question number 76. Of the given electronic configuration for the elements, which electronic configuration indicates that there will be abnormally high difference in the second and the third ionization energy? Okay, it is saying very large difference between second and the third ionization energy. Second ionization energy means when the second electron is removed. Third ionization energy means when the third electron is removed. Okay, the electronic configuration indicates that the element has one element. So the correct answer will be option number 2. So let's see how. Because one electron is in 3s state, another in 2p, then another will be in 2p. So there will be high difference. Okay, so let's check how. This electronic configuration indicates that the element has one electron in the 3s orbital. Removing this electron will require relatively little energy, which is the first ionization energy. Why low energy will be required? Because 3 0 state will be because we know 0 state, or we can say half filled or fully filled orbitals are more stable. Okay, so 2p6 will be more stable, hence it will so low energy will be required for going it to the fully filled state. Okay, however, removing the second electron will require significantly more energy because it must came from the inner 2p orbital, which is more stable and closer to the nucleus. This will result in an abnormal high difference between the second and the third ionization energies. Okay, that's why option number 2 is our correct answer. Now question number 77. Energy absorbed by each molecule A2 of a substance is 4.4 into 10 raised to the power of minus 19 joule, and the bond energy per molecule is 4 into 10 raised to the power of minus 19. The kinetic energy of the molecule per atom will be, okay, so we have to calculate the kinetic energy of molecule per atom. Okay, per atom. So let's check here. The kinetic energy will be energy absorbed minus bond energy divided by the number of atoms in the molecule. We will use this formula, and we know the energy absorbed is 4.4 into 10 raised to the power of minus 19 joule minus bond energy, and the bond energy is 4 into 10 raised to the power of minus 19 joule, and the number of atom in the molecule. So it is diatomic, means there will be two atoms in the molecule. Okay, so when we solve, it will come out 0.4 into 10 raised to the power of minus 19 divided by 2. Okay, if we solve this, we get 2 into 10 raised to the power of minus 20. So which is our option number 4. Now question number 78. The value of Planck's constant is 6.6 into 10 raised to the power of minus 34 joule second. The velocity of light is 3 into 10 raised to the power of 3 into 10 raised to the power of 8 meter per second. Which value is closest to the wavelength in nanometer of a quantum of light with frequency of 8 into 10 raised to the power of 15 per second? Okay, so here we have to calculate the wavelength. Okay, so here we have to calculate the wavelength. So we know wavelength is equals to c divided by frequency. Okay, this is the wavelength. Lambda denotes wavelength, c denotes the velocity of light, and v denotes the frequency. Okay, so the velocity is 3 into 10 raised to the power of 8 meter per second divided by, and here frequency is also given, and the frequency of light given is 8 into 10 raised to the power of 15. Okay, if we solve this, we will directly get our answer, which is 40 nanometer. Okay, so 40 nanometer means 40 nanometer, just 40 nanometer means 40 into 10 raised power of minus 9 meter, which is 4 into 10 raised power of minus 8 meter. So option number 4 is our correct answer. Now question number 79. Question number 79. The tendency of BF3, BCl3 and BBr3 to behave as Lewis acid decrease in which sequence? Okay, so we know the Lewis acidicity increase with the size of halogen. As larger halogen reduce pi as larger halogen reduce pi back bonding, making the boron center more electrophilic. Okay, so that's why the highest will be for BBr3, followed by BCl3, and then BF3 due to the Lewis acidicity increases. Okay, as the larger halogen reduces the pi back bonding, that's why. Okay, so correct answer will be option number 2. Question number 18. Consider the following isomerism, which is ionization, hydrate, coordination, geometric, optical. Okay, and the given compound is Cr, NH3 whole twice, OH whole twice, Cl2. Okay, so this is the given compound. So we have to tell which of the following isomerism it can show. Ionization isomerism is not possible because no ions are present outside the complex, outside the this complex. Okay, so it is not possible. Hydrate is not possible because H2O is not present as a ligand. Coordination is also not possible. Now we have to comment on geometrical and optical. Okay, so we can write chromium as M, then A2 and B2 and C2. Okay, and we know that the compound in the form of A2, B2 and C2, it can show both geometrical and optical isomerism, and optical isomerism. Okay, Ma2B2 can show both geometrical and optical. Okay, so correct answer will be option number 4. Now comes to question number 81. The D block element, which is a liquid at room temperature having high specific heat, less reactivity than hydrogen, and its chloride MX2 is volatile on heating is. Okay, so mercury is a liquid at room temperature. It has high specific heat, is less reactive than hydrogen, and its chloride HgCl2 is volatile upon heating. Okay, so mercury is satisfying all the conditions. So option number 2 is our correct answer. Now question number 82. Mercury is a liquid at 0 degrees Celsius because of very high ionization energy, weak metallic bonds, high heat of hydration, high heat of sublimation. Okay, so the explanation is mercury has weak metallic bonds due to poor overlap of 6s orbital result in its liquid state at 0 degrees Celsius. Mercury has a high heat of sublimation, which means it takes a lots of energy to change its state from solid to gas. However, its heat of vaporization is relatively low, making it easier to change from liquid to gas. Okay, so that's why weak metallic bonding, option number B and D, means weak metallic bonds and high heat of sublimation are our correct answer, means B, D. So that's why option number 2 is our correct answer. Now question number 83. Question number 83. Which of the following can't be used for oxidation of concentrated HCl? Concentrated HCl to chlorine gas. Okay, so PbO cannot oxidize HCl to Cl2, means we can't use PbO, it can't be used. But all other, means Pb3O4, PbO2 and MnO2, these are the strong oxidizing agent. Pb3O4, PbO2, MnO2. These all are strong oxidizing agents, so they can be used for converting concentrated HCl to the chlorine gas. But PbO is not a strong oxidizing agent, hence it can't be used. So option number 2 is our correct answer. Now question number 84. Consider the following ionization enthalpy in kilojoule per mole of two element A and B. Okay, so here are the information regarding the ionization energy. First ionization energy, second ionization energy, and third ionization energy. Now we have to observe and answer the answer which of the following is correct. Okay, so for element A, first ionization energy is around 900. Second is around 1800. You can approximately, you can say 1800. But the third ionization there is around 15,000, around 15,000 kilojoule per mole. So there is a very high difference between the second and third for A element. Now let's check for second. For second, first one is around 730, then around 1450, and there is huge difference between the second and third. Huge difference between second and third. Okay. So from this we can say that there is a large difference between the second and the third ionization enthalpy. Means both element A and element B belongs to the same group. They will be in the same group, and they will be in the second group. Okay, so they will be in the second group, and the ionization energy of A is higher. So A will be on upper side and B will be lower side, because we know while going from left to the right, ionization energy increases, and while going up to down, ionization energy decreases. Okay, that's why option number 4 will be our correct answer, which is both A and B belongs to group 2, but uh, B is below A. Okay, so option number 4 is our correct answer. Now question number 85. 1 gram of magnesium is burned with zero point 0.6 gram of oxygen in a closed vessel. Okay, which reactant is left in excess and how much? Okay, so this question can be answered by using the basic stoichiometric calculations. Okay, so first of all we have to calculate this. Basically this is a question of limiting reagent. Okay, now to solve this problem we need to calculate the number of moles of magnesium and number of moles of oxygen. Okay, so first of all we have to write the balanced chemical equation, which is 2 mg plus O2, it will give mgO, and in two amount stoichiometric coefficient will be 2. Now we have to calculate the moles of Mg and O2. Okay, so the moles of Mg and moles of O2 means 1 gram divided by its atomic mass. Okay, so number of moles of Mg is 0.04, and its number of moles of oxygen is 0.0175 mole. Okay, now according to balanced reaction, 2 moles of magnesium reacts with 1 mole of oxygen to give the 2 moles of product. Okay, so now here therefore the number of moles of magnesium that will react with oxygen is, okay, the number of moles of magnesium that will react with oxygen is 2 into 0.175. Okay, 2 into 0.175, because we have to calculate with respect to which is oxygen. We have to calculate with respect to oxygen. Okay, so the number of moles that will react with magnesium is 0.035. These are the number of moles of magnesium that will react. Okay, since 0.0417 mole of magnesium is there, so the we have to calculate the excess amount. So magnesium is an excess amount. Okay, so how much magnesium is an excess amount we can calculate by the number of moles which are present, 0.0417 minus 0.035. Okay, so the excess amount of magnesium is 0.0067 mole. So okay, so this is the excess amount of magnesium. Now we can calculate the its mass in gram by multiplying with the atomic mass, which is 24. Okay, So the answer will be 0.16 gram. 0.16 gram, which is option number A. Option number A is our correct answer. Okay, now let's come to question number 86. Which has the maximum number of molecules among the following? Okay, so here we have to calculate the maximum number of molecules. For this, first of all, we have to calculate the number of moles, and then moles, we have to multiply number of moles with the Avogadro number, which is 6.023 into 10 raised power of 23. Okay, 6.023 into 10 raised power of 23. So this value will be constant for all the four options. So the compound which have the highest number of mole will have the highest number of molecule as well. Okay, so first of all, for option number A means 44 divided by the mass of CO2, which is 32 plus 12, which is 44. Okay, now 48 divided by mass of O3, which is 16 48. Okay, now for clearly for option number C, mass of given mass is 8 and the mass of hydrogen is 2, which is 4 moles. 4 moles. Hence it is having the highest number of moles, means it will definitely have the highest number of molecules as well. Highest number of molecule as well. So option number C is our correct answer. Now question number 87. Strongest hydrogen bond is shown by. Okay. Strongest hydrogen bond is shown by water, ammonia, sodium fluoride or sodium sulfide. HF form the strongest hydrogen bond due to the high electronegativity of fluorine and the small size of fluorine atom, which enhances its bond strength. Okay, so option number C is our correct answer. The strongest hydrogen bond is shown by hydrogen fluoride. Question number 88. The stability of plus one oxidation state among aluminium, gallium, indium and helium increase in the sequence. Okay, so we know the stability of plus one oxidation state become more stable as we go down the group due to the inert pair effect, which is most pronounced in thallium. Okay, so the stability will be aluminium, then gallium, then indium, then thallium, because due to the inert pair effect the stability increases when we go from up to the down to the up to down in the periodic table. In the periodic table. So option number 2 is our correct answer. Now question number 89. If the energy of a photon is given as 3.03 into 10 raised to the power of minus 19 joule, then the wavelength lambda of the photon is. Okay, so energy is given and we have to calculate the wavelength. Okay, so we know energy is hc by lambda, and energy is given means 3.03 into 10 raised to the power of minus 19 joule. Then value of Planck's constant is given to us. Value of Planck's constant is given to us. Okay, 6.63 into 10 raised to the power of minus 34. Speed of light is also given to us, which is 3 into 10 raised to the power of 8, and we have to calculate the lambda. Okay, so by solving all this calculation we can get the value of lambda as this 656 nanometer. You can check the calculation from here. Okay, so option number C is our correct answer, which is 656 nanometer. Now comes to question number 90. Okay, which of the following is the correct option for free expansion of an ideal gas under adiabatic condition? Okay, under adiabatic condition. In adiabatic condition, there will be no heat exchange. So directly we can write Q will be equals to 0. Okay, so option number second is eliminated. Now in free expansion under adiabatic condition, there will be no heat exchange as Q is equals to 0. So when there will be no heat exchange, so no work done will be there, means W will be also equals to 0. Work done will be also 0, and temperature remains constant. And if the temperature remain constant, means change in temperature delta V delta T will also be equals to 0. So Q is equals to 0, work is equals to 0, and delta T is equals to 0. Means option number C is our correct answer. Now question number 91. The first ionization potential of beryllium and boron are respectively. Okay, we know while going from left to the right, the ionization potential or ionization energy increases, but beryllium has the fully filled orbital. That's why it has a higher ionization potential than beryllium. Okay, so option number 1 is rejected. Option number 2 is also rejected because the value is not equal. Beryllium has the higher value. Option number C is also rejected. So option number 4 will be our correct answer. If you don't know the exact value, then we can eliminate the option by our common concept or the basic concepts. Okay. So option number 4 is our correct answer. Now question number 92. Now let's come to question number 92. Yes. The given compound is CO, NH3, whole 4, NO2 twice, and then chlorine. Okay, so we have to find this compound can show which number, how many numbers of uh, isomerisms. Okay, so chlorine is so first of all, chlorine is present outside the complex, so it can show ionization isomer. Okay, it can show ionization isomerism. Okay, ionization isomerism is can show. Now let's check further. The complex can exhibit linkage isomerism due to the two possible coordination modes of NO2. Okay, yes, ionization isomerism due to the different arrangement of ligands and contraries, and the geometrical isomerism due to the arrangements of ligand in space. Okay, so it can show ionization isomerism. It can show linkage isomerism due to the linkage property of NO2, and it can show geometrical isomerism as well because I can write cobalt as M, then will be A4, then B2, and we know M A4 B2 can show geometrical isomerism. It can show geometrical isomerism. It can show cis and transform. Cis and transform. It can show cis and transform. Okay, so option number 1 will be our correct answer. Now comes to question number 93. Which of the following compound does iron exhibit zero oxidation state? Okay, so here we just have to calculate the oxidation states of all the compound. Okay, so in option number first, let oxidation state of iron is X, then for H2 it will be 0, and then NO3 it will be -1. No, it is outside the complex, so -3 is equals to 0. Okay, so iron is in +3 oxidation state. In option number 2, 3 plus X minus 6. So here it is also in +3 oxidation state. In option number 4, 4 plus X minus 6 is equals to 0, means X is equals to 2. Okay, so iron is in +2 oxidation state. But in option number in option number 4, the value that we take, oxidation number of CO will be 0. So X minus 0 will be equals to 0, means X equals to 0. So the oxidation state will be 0 in case of option number 4. Okay, now let's come to question number 94. Al2O3 can be converted to anhydrous AlCl3 by heating with, okay, a mixture of Al2O3 and carbon in dry Cl2 gas. Okay, carbon reduces Al2O3 to aluminium, which then reacts with dry chlorine gas to form anhydrous AlCl3. Okay, so option number 2 will be our correct answer. Okay, first of all, a mixture of Al2O3 and carbon converts the uh, aluminium Al2O3 Al2O3 and carbon in dry Cl2 gas. Carbon reduces Al2O3 to aluminium. It will reduce Al2O3 to aluminium. Then in dry chlorine gas, it can form anhydrous AlCl3. Okay, so option number 2 is our correct answer. Now comes to question number 95. Which of the following statement about H3BO3 is not correct? Okay, So first is it is a strong tribasic acid. It is prepared by acidifying an aqueous solution of borax. It has a layered structure uh, in which planar BO3 unit are joined together by hydrogen bonds. It does not act as proton donor and act as Lewis acid by accepting a lone pair of electrons. Okay, so first of all, the statement 1 is incorrect because it is not a tribasic acid. It is a not a tribasic acid. H3BO3, this is not a tribasic acid. Remember this statement. This is a very important. Okay. And all other, it is prepared by acidifying an aqueous solution of borax. Yes, this is correct. It is a layered structure in which planar BO3 units are joined together by hydrogen bonds. Yes, all other statements are correct, but statement number 1 is incorrect. It is not a strong tribasic acid. Okay. Now comes to question number 96. Question number 96. The vapor pressure of two liquid P and Q are 80 torr and 60 torr respectively. The total vapor pressure of a solution obtained by mixing 3 moles of P and 2 moles of Q will be. Okay. So we have to calculate the total pressure. Okay. So the vapor pressure of P is 80 into its mole fraction, which is 3 by 5 plus 60 into 2 by 5, the vapor pressure of Q into the uh, mole fraction of Q. Okay, so if we solve this, we will get the value as 72 torr. So correct answer will be option number 1. Now comes to question number 97. Blood cell retain their normal shape in solution which are. Okay, blood cell retains their shape in isotonic solution where solute concentration matches that of blood. Means the solution means isotonic to the blood. The solution which are isotonic to the blood. So option number 2 will be our correct answer. Now question number 98. The ionic conductance of Ba2 plus and Cl minus are 127 ohm inverse centimeter square and 76 at infinite dilution. Okay, the equivalent conduction, we have to calculate the equivalent conductance of BaCl2 at infinite dilution. Okay, so the reaction will be BaCl2 will gives Ba2 plus 2 Cl minus. Now, okay, so conductance of BaCl2 will be equals to conductance of Ba2 plus 2 time conductance of Cl minus, which is 127 plus 2 into 76, which gives the value of 279. Okay, but since BaCl2 is a divalent electrolyte, we need to divide the molar conductivity by 2 to get the equivalent conductivity. Okay, so 279 divided by 2 will be 139.5. Okay, so our correct answer will be option number 1. Now comes to question number 99. 4.5 gram of aluminium, atomic mass 27 unit, is deposited at cathode from Al3 plus solution by a certain quantity of electric charge. The volume of hydrogen produced at STP from H plus ion in solution by same quantity of electric charge will be. Okay, so we have to calculate the volume of hydrogen at STP. Okay, so first of all, the moles of aluminium will be given mass, which is 4.5 gram divided by 27, which is 1 by 6. Okay, now from the balanced equation, the balanced equation will be 2Al plus 6H plus will gives 3 times of hydrogen gas plus 2 times of aluminium 3 plus ion. Okay, now from the balanced reaction we can see that 2 moles of aluminium produces 3 moles of H2. Yes, 2 moles of aluminium are producing 3 moles of hydrogen gas. Okay, so 1 by 6 moles of aluminium can produce 1 by 6 aluminium moles of aluminium can produce 1 by 4 mole of H2 gas. As 2 moles of aluminum is producing 3 moles of H2 gas. That's why 1 by 6 moles of aluminum can produce 1 by 4 moles of H2. Okay, we are doing the basic calculation. Okay, so for 1 by 4 moles of hydrogen, we can calculate the volume at STP. Okay, for 1 mole, the volume of STP will be 22.4 liter, 22.4 liter. So for 1 by 4, it will be 1 by 4 into 22.4. Okay, which will be equals to 5.6 liter. Okay, so the correct answer will be option number 4. Now comes to the last question, question number 100. Which of the following statement for the order of a reaction is incorrect? Okay, order can be determined experimentally. Yes, this is correct. Order is not influenced by the stoichiometric coefficient of the reactant. No, order is not influenced. Yes, yes. Order is not influenced by the stoichiometric coefficient. Okay. Order of the reaction is the sum of power of the concentration term of reactant to express the rate of reaction. This is also correct. The order of reaction is always a whole number. This is not correct. It can't be always a whole number. Okay. So let's read the explanation. The order of a reaction is not always a whole number. It can be fraction, especially in case involving complex mechanism or intermediates. The order of a reaction is determined experimentally and can be fractional, zero, or even a non-integer. Therefore, the statement order of a reaction always whole number is incorrect. So option number 1 is our correct answer. So option number 4 is will be our correct answer. Option number 4 will be our correct answer. Okay, so thank you guys.